nuclei and what might cause them to be unstable. And we discussed that that was when the strong nuclear force, which is holding the nucleus together nice and tight, isn't quite strong enough to overcome that repulsion that the protons want to do away from each other. So we're now going to look at, for this short video, what is alpha decay, because any type of decay when we're talking about nuclei is a process that they can do to become stable where they were unstable. So we're going to use our lithium example again, because I do love a little lithium. So lithium has that mass number of 7. We use A to mean mass number, because I don't like writing mass number every time. And the fact that it's 7 tells us that there are 7 particles in the nucleus. And here we go with those 7 particles. There is lithium with its atomic number of 3. And that tells us that there are 3 particles in that nucleus that are positive protons. And positive protons we're using with red here, and we can see their big plus signs. So at the moment we're going to say that this nucleus here is unstable. That strong nuclear force isn't quite enough to hold this nucleus together. So what this nucleus is going to do is it's going to emit something or give out a particle in order to become stable again. So at the moment it is unstable, and if it's alpha decay that we're talking about, this nucleus is going to emit, and that's my big green arrow here, it's going to kick out a little alpha particle. And alpha particles are made up of 2 protons in red and 2 neutrons here in white. So we can see that from the nucleus we take these 2 protons and 2 neutrons here, like this, and they get kicked out, they get booted out of that nucleus. And that is enough to bring the nucleus back down to being stable again. So this little alpha particle down here has been kicked out, it's been emitted, and now, so we're in the after scenario, our nucleus is now stable. There's 1 proton and 2 neutrons have been left behind. Now, if we've got a nucleus where there are 3 particles in the nucleus, we're going to need to give that a mass number, an A of 3. And we can see that there's only 1 proton left, so that means its atomic number is going to be 1. So this atom that's left behind now is no longer a lithium, because in order to be lithium you have to have 3 protons, but this has only got the 1. So this atom that has been left behind, I've just drawn the nucleus of the atom rather than the whole thing, this now is a hydrogen atom. I know that because hydrogen is the only element in the periodic table that's got an atomic number, a Z, of 1. So I've got a hydrogen now, and I can draw this as an equation. So we start out in the before scenario with a lithium, with a mass number of 7 and an atomic number of 3. But remember, this was unstable. So I'll write that on. This is unstable. And in order to become stable again, it is going to emit or kick out an alpha particle. And we write an alpha particle using this symbol alpha. And it's got a mass of 4 because it's made up of 1, 2, 3, 4 particles, and it's got an atomic number of 2 because 2 of them are protons. So we've got alpha, 4, 2. And then we also put a plus sign because we've got to show what was left behind in the after stable scenario. And just like I'm going to take that from down here, it has, I should say, a mass number of 3 because 1, 2, 3 particles. It's got an atomic number of 1 because we've just got the 1 proton, and we know from our knowledge of the periodic table, or we can look it up, that makes it hydrogen. Now this is the example of the decay equation for alpha decay of lithium. We can actually put that into general terms as well. So down here I put it into general. So if we don't know what the atom was, we use the letter X. And we know that we use A to mean mass number, we've used that up here, and we use Z to mean atomic number, and we've written that here. So we start out with any, so this is in general terms, any unstable atom. And it's going to go through alpha decay in order to become stable again. And we know how to write an alpha particle now. We use our alpha symbol with a 4 and a 2 to show a mass of 4, and 2 of them are protons. This gets emitted. It's not terribly clear to see, but that does say emit. And then we need to give some people some guidance for how to write what's left behind. So to do that, we say that it's the A, the mass number, take away 4, because of the 4 particles that have been emitted, and Z, the atomic number, take away 2, because we know that if you're going to emit an alpha particle, 2 of those 4 are going to be protons. So Z, proton number, take away 2. And because the proton number, the atomic number, has changed, we can't write X anymore because it's a different atom now. It's a different element. So we use the letter Y instead. And I'm just going to write down at the bottom that this is now nice and stable. And what's left behind? Okay, so that is alpha decay. So what is alpha decay? It is the emitting, the kicking out, the removal of an alpha particle in order to make the nucleus nice and stable again.